computing offers will already have been taken. Or if you look at the tons of consultants out there, like the Dilbert cartoon tells you, we have got a lot of people who are trying to be more philosophers at this moment, trying to tell you why to jump onto the cloud without actually having practical experience of the cloud, without understanding the customer needs. So it is something which is between hype and reality. It's probably another couple of years. We'll soon see the cloud computing to become a reality, and large scale adoption to is bound to happen. So what are the cloud enablers? So we saw outsourcing is something which enterprises have been doing to reduce the costs. Along with that, the advent of high-speed internet has enabled the data center and the user distances to be higher. So as long as you're good enough bandwidth, you can reach your data center, which could be located anywhere. Coupled with that is your processing performance. So we have seen Intel moving on from the processors from Xeon 5500 series, which is the 4-core, to the 7500 series, which is an 8-core processor. And now Intel already has a outline for a 16-core processor. So as the processing has has become more and more, and the amount of addressable memory has increased, that has enabled virtualization. So you have enough memory and CPU power for having multiple machines on the same physical machine. That, in fact, is one of the main pillars for cloud computing, virtualization. Mobile has taken off in a big way. There are more mobile devices than PCs in the world. So that is also creating a new class of applications for the cloud. And again, mobiles are probably more connected to the internet than the PCs. So let's look at virtualization, the key pillar of the cloud. So here is our virtual infrastructure. On top of it, you have virtual machines. So the virtual infrastructure could be the kernel, just like the VMware kernel, which is capable of talking to the storage, the network, and these servers at the backend. So inside, you are capable of running multiple operating systems and applications on the same physical server. Different types of virtualization. So it started long ago, where even things like a virtual LAN, of course, virtualization is something which has been existing for decades now. It's nothing new. But companies like Cisco bought over the switching equipment and modified it so that now we can have multiple smaller LANs within the main switch, which is the virtual LAN, or offering this as a service to the end customer. So where you have a bank A and a bank B both connecting to the same provider, but their data is not shared. That is the VPN, or the virtual private network. Even in the storage world, there is vSAN, which is Cisco proprietary at this moment, but essentially gives you the capability of doing zoning, LAN masking for every vSAN separately, just like you did for VLAN. VLAN and vSAN are more or less equivalent. And finally, the virtual machine. So virtual machine is what we are knowing as virtualization, because the hype around the virtualization has started after VMware went mainstream. So let's quickly look into the cloud computing blocks. So virtualization, as we have seen, is one of the biggest pillars for cloud computing. Along with that, storage, the amount of storage which you can have, the disks are becoming smaller and smaller, but the capacity inside the disks is growing each day. So the same form factor of the 2.5-inch disk, which was capable of having a few MB a few years ago, is now carrying a couple of 100 GBs right now, and probably even terabytes. Management of the cloud as well as management of the internal equipment is a key component of the cloud computing. Integration of all equipment, integration of the software which will be controlling the components, allowing you to integrate the FCAPS or the TMN, which is your OSS BSS platforms. And on top of it, you put the orchestration layer, which basically is able to talk to each of these areas and is capable of delivering the service on top. So what services which will be running will be, we have seen the IaaS, the PaaS, the SaaS. Those are the services which we have been talking about. So when you go on to the journey of virtualization, it's not an easy journey because the number of customers which I worked with, most of them failed to identify the basic problem. Most of them immediately said, yeah, we have the issues that we have got too many servers, but they were not able to identify what exactly was the problem by having too many servers. Was it that they were low on the disk utilization? Was it that they were low on the memory utilization? Was it that their power utilization was very high? They were not able to quantify the effort or the management cost, but probably most often the problem is one of these, and that's what needs to be quantified. So you build your business case around it. So you say, virtualization, why do we need to virtualize our environment? Why do I need to reduce the amount of servers? So if you tell them that, hey, you know what, I'm probably this one rack will get reduced, so probably I'm going to draw a few kilowatts less. Now that translates into an immediate business case for the business folks. At the same time, you must create a budget for your virtualization. So how much it will cost for you to build, how much will it cost you to be operating it, and finally get the trained manpower. Now that's the virtualization if you're trying to do it yourself. Or you could simply go to a cloud service provider and not bother about all of these. So let's look at the virtual machines. So without virtualization, if you see on the left hand side, you have the server, physical server running a single operating system and probably a single application. So as your power has grown, as the density of servers have grown inside a single rack space, which you have the blade server chassis inside which you keep on pushing the blade servers, you are capable of running a virtual kernel on which you are running the operating system. So the operating system thinks that they have got their hardware of their own and they are able to make calls to the hardware. So internally you can have many applications running, thereby utilizing your memory better, utilizing your CPU better, utilizing your disk better, but at the same time getting you a better power utilization. So that is the big benefit what virtualization gets you to from a server standpoint. But even from a desktop standpoint, virtualization helps because I may not have a PC or a laptop dedicated for anyone. I could give the same device to people, and when they come in, they just log into that device and they get their own environment. So if they run Windows software, they get the Windows software. If they run Linux, then they get the Linux and they get their applications on top of it. This is also referred to as virtual desktop infrastructure or the VDI. Network virtualization, we have already talked about the VPNs. So on the same network, you have the provider edge devices which connect to the various customers and allow them to share the same network to create their own private infrastructure, or the VLANs which exactly do the same thing but inside your office. Taking this a further step, Cisco's Nexus, which allows you to create the VDCs or the virtual device context, in which you could now create the set of physical and logical interfaces into the virtual device context. So you could have a separate routing protocol running, separate VRFs running in one virtual device context, and another one which runs across another device context. Virtual firewalls is something which has been going on for years. So you can separate a big firewall and have smaller firewalls within it. So these are some of the components of the network virtualization. Data centers in the past, we had built up the LAN switch, the SAN switch. So the LAN switch would connect to the LAN, the SAN switch would connect to the storage area, so that the servers had a dedicated channel to speak to the user side, as well as they had a dedicated channel to the storage side. So the performance on that port was much better. But that increased the number of cables onto the servers. That also increased the power usage because as well as the number of ports to be configured. Plus, it required the expertise of both the SAN as well as the LAN on the server side. Now what Cisco did is they consolidated the SAN onto a technology called fiber channel over Ethernet. So what happens from a server standpoint is this same 10 gigabit Ethernet, which is an uplink to the fabric interconnect or the unified fabric. So what it does is essentially it is capable of taking the Ethernet frames and stripping off and sending it to the SAN island or to the LAN island. So from the server standpoint, now the number of cables are reduced, the number of ports are reduced. So it's all about unification, which is going on at this moment. So there's a lot of consolidation even in the data center world which is happening. So let's quickly focus on the virtual machine. Here is our virtual machine in which we have different applications, and each of these applications is running on the same physical hardware. So here is your main hardware which you are looking at. On top of it, you are having application A, which is running on Windows 2008, B, which is running, let's say, on Fedora, C, which is running on Ubuntu, and D, which is running on the Macintosh. If you see these gray blocks, these are all the network interface cards. Now, these are not the real network interface cards. These are the virtual network interface cards, or as in the VMware language, these are called as VMNICs. So these are presented to each of the applications, and inside of the server, inside of the VMware kernel, you have a virtual switch which connects all these applications, or rather connecting all these servers to the physical network. So all the calls to the physical network are made by the vSwitch, and inside all reachability from the server onto the network interface card is handled by the vSwitch. So the end application doesn't even talk to the physical network interface card. So from the network perspective, you see calls are being made from many MAC addresses coming out of the same physical port, and you're able to tie up things like even having a virtual firewall inside for some applications or some operating systems to isolate them from the others. Thank you for tuning in, and see you until next time.